Welcome to this fascinating journey into animal behavior. Today, we are going to explore one of the most deceptive and thrilling phenomena in the natural world, code breakers. Imagine a world where your deepest instincts are used against you by cunning biological hackers. We will uncover how certain species exploit the hardwired behaviors of others for their own selfish gain, and why evolution allows this dangerous game to continue. Let us dive in and decode this incredible evolutionary puzzle together. To understand our topic, let us start with a simple analogy. Imagine you have a secret password to enter your private treehouse, shared only with your closest friends. One day, a clever stranger hides in the bushes, listens carefully, and memorizes your exact password. The next day, they speak the password, and you automatically open the door, letting them eat all your snacks. You were not outsmarted in a physical fight. Instead, your strict rule of always opening the door for the password was completely exploited. In the animal kingdom, this exact scenario happens every single day. Now that we have our analogy, let us look at how this works in nature. In ethology, a code breaker is a species that has evolved to perfectly mimic the specific sign stimuli used by another species. They are essentially biological hackers. By presenting a fake version of a sign stimulus to a host animal, the code breaker hijacks the host's biological communication system. The host is tricked into responding to a signal that isn't real. Essentially, the code breaker has cracked the host's biological code, manipulating its nervous system for its own survival. You might be wondering why the host falls for this trick. The answer lies in fixed action patterns. Many animals rely on these innate, hardwired behaviors for survival. These patterns are triggered by specific environmental cues, which we call sign stimuli. Because the host's response is completely instinctual and automatic, it literally cannot help but react when it sees the cue. Even when the fake signal is clearly harmful to its own survival, the host's brain forces it to complete the action. The code breaker exploits this exact automatic nature of the host's instincts. Understanding this dynamic is absolutely crucial because it highlights the hidden vulnerabilities of innate behaviors. Fixed action patterns are highly efficient for survival in a predictable environment, but they can become deadly traps when another species figures them out. This creates a perfect real-world illustration of an evolutionary arms race. The host species constantly tries to evolve better, more complex passwords to protect itself, while the parasitic code breakers simultaneously evolve better ways to fake those exact passwords. It is a continuous, high-stakes battle for survival driven by natural selection. This brings us to a fascinating evolutionary dilemma. You might wonder, why does the host species not simply evolve to stop responding to the hijacked signal altogether? It seems completely illogical for an animal to repeatedly fall for a trick that costs it dearly, like a tiny bird feeding a massive parasite chick that just killed its own babies. However, nature does not operate on human logic. It operates on mathematical probability. By looking at the math, we can see exactly why natural selection forces the host to keep playing this dangerous game. To understand this dilemma, we use a mathematical model based on expected payoff. This formula calculates the average evolutionary benefit of responding to a signal over time. Let us break down the equation. E represents the expected evolutionary payoff for the host. The variable p is the probability that the signal is actually coming from an honest member of its own species. B stands for the reproductive benefit gained if the signal is real, like feeding its own offspring. Finally, C represents the severe evolutionary cost suffered if the signal is fake. As long as fake signals are rare, the expected payoff remains positive, and the instinct is preserved. Before we move on, let us see this with a concrete example involving the reed warbler and the cuckoo bird. A female warbler hears a begging chick. There is a 95% chance it is her own, giving a benefit of 20 units. But there is a 5% chance it is a cuckoo, carrying a massive cost of 100 units. We plug these values into our formula. Multiplying the probability of success by the benefit gives 19 fitness units. The probability of being tricked multiplied by the severe cost gives a penalty of 5 units. Subtracting these gives a final expected payoff of 14 fitness units. Because this is positive, the warbler must keep her feeding instinct. Now that we have calculated the math, let us look at what this actually looks like in nature. In this diagram, you can see a tiny adult reed warbler perched on the edge of its nest. Inside the nest is a giant cuckoo chick, which is significantly larger than the adult bird feeding it. Notice the cuckoo's massive, bright red, wide-open mouth. This acts as a supernormal sign stimulus, an exaggerated fake signal that overwhelmingly triggers the warbler's hardwired feeding response. The visual perfectly captures the tragedy and power of codebreakers. The tiny host is mathematically forced to feed a giant imposter because ignoring the signal would mean starving her own true babies most of the time. Let us explore another fascinating scenario, the femme fatale firefly. Male Photinus fireflies flash a specific light pattern in the dark to find females of their own species. The females flash back to invite them over for mating. However, female Photurus fireflies act as deadly code breakers. They perfectly mimic this exact return flash to lure the unsuspecting males in, not to mate, but to eat them. The male firefly faces a terrifying choice in the dark. He must determine if the evolutionary drive to reproduce outweighs the fatal risk of being eaten by a predatory code breaker. Let us apply our formula to this deadly encounter. Suppose the probability of finding a true mate is 70%, yielding a reproductive benefit of 40 units. The probability of encountering the predatory code breaker is 30%, carrying a fatal cost of 80 units. We set up the equation. The expected benefit from honest encounters contributes 28 units to his fitness. The negative impact of predatory encounters drags his success down by 24 units. Subtracting these gives a final expected payoff of 4 fitness units. Although the margin is incredibly slim and the risk of death is high, the payoff is still mathematically positive. Therefore, the male firefly will continue to blindly fly toward the light. We have covered the full topic of code breakers, so let us review the most important ideas. First, code breakers are biological hackers that perfectly mimic the sign stimuli of other species. Second, by doing so, they bypass the host's defenses and hijack their hardwired fixed action patterns for selfish gain. Third, whether it is a cuckoo stealing parental care or a firefly luring a mate to his death, instincts are powerful but highly vulnerable. Finally, as long as the evolutionary math yields a positive expected payoff, the host species will remain trapped in this incredible cycle of deception.
you now understand the fascinating mathematics behind animal deception.